Go ahead.
Okay, so hi, my name is Natalie. I'm going to talk to you guys today a little bit about myself, what kind of research I did during the summer. So I'm 20 years old. I'm from Westerville, Ohio. It's like basically right here in Columbus. And right now I go to school at the Ohio State University. And Ohio State is big on football. And I was really excited to come to school here because I really like football. And I made a bunch of new friends, and they all like football too. So we go to games together, and we watch games together, and it's a lot of fun. And we do other things together too. We go to the zoo during the winter, during zoo lights, and that's fun. We dress up for Halloween. Does anybody want to guess who I am in this picture? No guesses? I'm actually 2 Chainz right here. Somebody dared me to do it, so I did it. I don't back down. But I go to Ohio State and I study. I'm an engineer. And during the summer, I was doing research, and in the lab, we do something called DNA origami. And I was like, DNA origami, what is that? How can two things so different be related at all? So start with DNA. What do we know about DNA? Well, that's the thing that's in the cells in our whole body, and it's the thing that makes us who we are. It gives us all of our physical characteristics, like eye color and hair color, and how tall or how short we are. But what does that have to do with folding paper into paper swans and those sort of things? So, turns out you can take strands of DNA and actually fold them into shapes and objects. And it started off with things like stars and smiley faces, but those aren't really useful. So then we started making things like beams and gears and blocks, and you can start building these tiny little structures. You can't even see them. It's crazy. And this summer I was working with something called a force transducer. And force transducer design is right here, and it basically acts like a spring. It just looks a little bit different. So when you squeeze a spring, it shortens the length of it. When you pull on it, it lengthens it. And what we can do is measure tiny little forces and kind of create a bed, like a mattress of springs. And when a cell moves across that surface, it'll kind of squeeze the springs, and that's something that we can measure. And we're hoping to apply this to cell research in cancer and other diseases.
So